Okay, so in this question, I have a parachutist that drifts down at a constant velocity of 5 meters per second. When she is at a height of 200 meters, her boyfriend throws a physics textbook upwards towards her at an initial velocity of 60 meters per second. Now, how high will the text be when the parachutist and the text are at the same height? So number one, like always, I would like to draw a picture for this question, and this is how we're going to start. So we have my parachutist coming down at a constant velocity of 5 meters per second, and then at a height of 200 meters. So let's say if I consider the ground to be my 0, my height over here would be 200 meters above the ground. And let's say her boyfriend's standing right here, and he throws a textbook upwards to her at 60 meters per second, so it's going upwards pretty fast. And at some height, so let's say as this parachutist is coming down, so as the parachute is coming down, the textbook is going upwards, and then at the specific height, which I'm going to call X, they will meet. On the side note, I just want to talk about the book for a second. So this parachute is going to come down at a constant velocity, but the book is going to go up. As you know, it's going to stop at certain points, so the velocity is just going to equal 0 at this point, and it's just going to fall back down, right? So this is what's going to happen to the book. So let's see what I have in terms of data for my parachutist. My parachutist is going down at 5 meters per second, so I'm going to include the negative sign here. The acceleration for my parachutist is 0 meters per second squared because we are ignoring the g at the gravitational constant of Earth, and because we know because of the parachute, the parachutist is going to come down at a constant velocity, and constant velocity always means 0 acceleration. Okay, so now that we know that, I'm just going to write down what I know for my for my textbook. My textbook is going upward, so the initial velocity for the textbook is going to be positive 60 meters per second. Now, since the velocity of my book is just going to go up and come back down, and it's changing because of the acceleration of Earth, so the acceleration of my textbook, it would be negative 9.81 meters per second square, and because it's going downward, I'm going to consider the negative sign here. Okay, so at some point, which is X, so my final position for my textbook, so my D final for my textbook is going to be X, and my D initial for my textbook is going to be 0. Therefore, my delta D for my textbook is going to be my dF2 minus dI1 equals my second one is X and my first one is 0. Therefore, it's just going to be X. So that is the change in distance. How about for my parachutist? So for the parachutist, my final position would be X. So that's my dF for my parachutist. It would be X. And then for my initial for my parachutist, I start at 200. So my DFP minus DI, so initial position of the parachutist. My final height would be at X. So this is X where they're actually going to meet. And my initial height was 200, which I'm going to write here. All right, so now that we have this written down, I want you to pause the video and tell me what equation you're going to use to solve this question. Attempt this on your own and then come back and check the answers with me. Okay, now that we're back, I've written all the data down here, and I'm going to pick this equation. I'm going to pick delta D, VI delta T, plus half of A delta T squared. Well, why did I choose this equation? Because in this equation, I have my delta D known, which I know from here. I know my initial velocity over here, and I also know what the acceleration is in the for the parachutist. So I can actually use this equation for the parachutist to solve for t. And what does this t give me? T is the time that the parachutist and the textbook meet at the height of x. All right, so let's plug in my data to find out what we can find for time here. Now for delta D, I will plug in x minus 200. And then for my initial velocity, I have -5. And for t, it's unknown, plus half of a, which is 0, delta t squared. Now this we're going to get rid of because anything multiplied by 0 is just 0. There, and therefore I have just one equation here, which is x minus 200 equals minus 5t. Now, what am I looking for here? I am actually looking to, so I can actually rewrite this as x equals -5t, and I'm just going to bring the 200 to the other side, so I have plus 200. So I've actually solved for x, but I don't know what t is. If I knew what t was, I could just plug it in and find out what this height is. So if I could just have another equation for x, and I could get it from here, I can put it equal to this and solve for t. Okay, so let's do that. I want you to pause the video and do this part on your own and get back. Okay, I'm going to choose the same equation for the second part. So I will have delta D equals VI delta T plus half of A delta T squared. All right, now for my delta D, what do I have? For the second part, delta D is equal to x, so I have x equals something. Now you're looking at this, we are getting somewhere. I am getting another equation for x, which is perfect, which is exactly what I was going to do. Now for my initial velocity, I have a positive 60, t is unknown, plus half of a, which is -9.81, and then I have my t squared. Now, if I were to simplify this a little bit further, I will just have x equals 60t. -9.81 divided by 2 is just -4.9 t squared. Great. So now I have two equations and two unknowns. So I have equation number 1 and equation number 2. I'm going to write my equations here, and the next step is to actually put, if x equals to this and x equal to that, therefore these two are equal to each other. So I'm going to put these equal to each other, and I will end up with -5t plus 200 equals 60t minus 4.9 t squared. All right, I can actually rearrange this, right? It looks a little bit messy. So what I'm going to do is that I want to have this as a positive number. So I'm going to take this to the other side. I'm going to write it at 4.9 t squared. I'm going to keep -5t here. I'm going to move 60t to the other side. So I will have -60t. And I'm going to keep 200 here. And I'm going to have nothing on the right side, so I'm going to have it all equal to 0. This could be simplified furthermore, so I will have 4.9 t squared minus 65t plus 200 equals to 0. Now, what does this look like to you guys? This looks like a quadratic to me. What is a quadratic? what does the quadratic equation look like? So I have usually ax squared plus bx plus c equals 0. This looks a lot like a quadratic equation. Okay, so in this case, I will have my a as 4.9, b as negative 65, and c as positive 200. And if you recall the quadratic formula, it's always t1 and t2 equals negative b plus minus b squared minus 4ac over 2a. Okay, we all remember that. Now all I need to do is plug in my values here, and I will find what my t1 and t2 are. Okay, so what is negative b? So minus negative 65 is just a positive 65, plus minus 65 to the power of 2 minus 4 times my a value times my c value, and that's divided by 2 times 4.9. So if you guys can do this fast, you can do it, plug it in into your calculator and get the answer right away. But I'm just going to show you how to do this step by step. So the first step is to calculate what's under the radical here. So I have 65 to the power of 2. So if I plug that into my calculator, I get 4225. And then I have a minus sign, and then I have 4 times 4.9, which is 19.6, multiplied by 200. So I have 3920. And then 2 times 4.9, plugging it in into my calculator, I will get 9.8. All right, great. So what's underneath here? So I'm going to do that. So I have 4225 minus 3920. It's 305. If you take the square root of 305, you're going to end up with 17.46. So I'm going to round that up to 17.5 divided by 9.8. All right, so now I have two options for my t. I can have 65 plus 17.5 divided by 9.8, or I could have 65 minus 17.5 divided by 9.8. Okay, so this will give me my t1, this will give me my t2, for example, or whatever you want to call it. Or let's actually name it this way. I will explain why later. Okay, so for the first one, if I plug in 65 minus 17.5, which is 47.5, divided by 9.8, it should give you your T1, which is 4.9 seconds. I'm going to round it up to 4.9. And for my T2, I should have 65 plus 17.5, which is 82.5, divided by 9.8, and it should give you 8.4 seconds. So I have 2 times. What does this mean? Why do I have 2, and which one is the right one? Okay, so let's go back to my picture here. This is why it's really nice to draw a picture. So when I throw this book up, right, what happens is that, and this parachute is coming down and they're going to meet at X. So this is where I have my T1. This is the first time they have they're at the same height. Now then what happens is that the parachute is going to continue going down here. So let's say at sometimes later when the parachutist is here, the book is actually going to make a trip up and come back, and they're going to meet again at a different height. So let's call this at a X new, at a new height. So T2 represents the time parachutist and the textbook meet at the new height, so at x new. All right, now hopefully it's clear why we picked the first one to be my T1, because first they meet at 4.9 seconds, and then second they meet at 8.4 seconds. So that's when the book is actually going to start falling back down towards Earth. All right, so now that I have T1 and T2, I want to actually find my X using that and my X new using this one for part A, and this I'm going to use for part B. So let's go on a new page. My T1 is 4.9 seconds. I can actually use this, plug it back to one of these equations. You can pick whichever you want. I'm going to pick the first one because it's the easiest one. I have x equals negative 5t plus 200. So plugging in my values, I have negative 5 times 4.9 plus 200. So negative 5 times 4.9 is negative 24.5 plus my 200. I will have 175.5 meters. So this is the height where the book and the parachutists are going to meet at first. So this answers my question in part A. So for part B, if you go back to the question here, it says if she misses the text on its way up, how many seconds later will she get a chance to catch it again? So this, we're talking about x new here. So we can actually calculate it as we said using T2, which was 8.4. So for B, T2 was 8.4 seconds. Plugging it into the original equation, and we can use the same one because this explains the whole journey of the parachutist, which is actually going to fall back down. So I have negative 5 times 8.4 plus 200. Now this one I have 5 times negative 8.4, it's negative 42 plus 200, it's at 158 meters. And that makes sense. This one, your x new is actually smaller than your first one. And if you actually look at the picture, you see that it makes sense because x new is lower, right? So over here is your x new, and the blue part is your actual x the first time they meet. All right, so hopefully this was clear. If you have any questions, please don't be afraid to post it under our video. You can email us or go on our website under our forum, so www.helixacademy.ca. Post any questions you have and we will be sure to get back to you. Thank you so much for watching.